What's up guys, welcome back to the channel. So today, I wasn't actually going to film today at all, but I'm doing some conduit work. It's quite a nice little thing, so you can see the board, you can see where it's going to. So I thought I'd show you some little hints and tips about how to get over some of the issues around forming conduit and things like that, and also when it marks like hell as well in your pipe rack as well. I'm going to show you how to get over all that. So if you're new to the channel and you haven't subscribed yet, hit the link in the corner, turn your notifications on, and yeah, let's get stuck into the video. So before I go any further, I'd like to point out this is literally a boiler room. I've got full control over it, so nobody else is going to be coming in and out, okay? So just bear that in mind. So what I'm going to do, what the job is is I've got to get a new 16 amp supply to there to power that solar boost, okay? So what I've done is I've gone round and done the conduit like this. There's a little step and stuff in here, and then back to the board, okay? So this board here is all RCD protected, but at the other end, this is a sub board. So what I'm going to do is I'm going to show you how I go about doing all this. We're going to go through the testing procedure on this as well while we're at it, and then I'm going to show you as well how to get over all like the black marks and scuffs and things like that you get on that are really tricky to get off, and inevitably it always happens. So especially for me, because I keep loads of different pipes and stuff in the pipe rack, you know, obviously I've got copper, I've got some galv in there, there's all sorts of bits and bobs, so there's always going to be some scuffs unless I've been and bought a brand new one for the job, which I haven't. So this is me genuinely fitting it out as we speak. So as you can see, it's a tight old area, there's not much room to manoeuvre, so that is also one of the things. So where we're at right now is I've managed to get my cable through. Yes, I could have used singles, but I haven't used singles at all because I don't need to, I can get it through. I'm going to show you another little way of getting that through as well, which makes life a bit easier. So where we're at the minute, the other end is prepped. This end obviously is through here. I've got to isolate all the power off before I go any further now, because I've got to drop in a 16 amp MCB that's going to be going in there, which I'm going to tuck into that end. But let's go and show you the conduit at the other end. So let's go into the hallway. Okay, so we're going to need some conduit. Okay, so this is just 20mm conduit. So if you can see that, how scuffed and marked that is. So all the way down, like that way especially. I mean, obviously if it's back against the wall, you're not going to see it, so it's not a problem. So things you're going to need is obviously some conduit. You're going to need a bending spring, old school. Attach a bit of cable to the end of it, because you're going to show you why you're going to need that in a minute. Just had a tea made for me. Cheers, Tez, thank you very much. So you're going to need that. Going to use some big wipes, and also a bit of an abrasive pad for me. Now, I'm not going to claim that I have come up with this completely on my own, because I saw it the other day and I thought I'm actually going to share it with you guys. So what we're going to need to do is use your big wipes, and it's a lot of the time you'll think, oh yeah, the big wipes will get everything off. It doesn't. It does do 90% of it. So what I found is on the really tough bits like that, as long as you've rubbed it first with that, use your abrasive pad and take that off, because then it's not too, so you want a fine pad, you don't want anything too mental. And you basically just work your way through it, like that. And I think you can see, so then if you use a bit of a rag basically, and I think you'll agree that that end is now nice and clean. Okay, so if you compare that to further down the line, she's pretty damn good. So that's cool. That's one way to clean the rest of that conduit off, because you need to make sure it's all nice and clean. So the bending, okay, so obviously I already got a short length, I've got a tight area. So if you need to be putting a bend in on a full length, the idea is you whack that in. So let's say you've it's a full length and you need a bend out here, you line up your conduit end to where it needs to be, like so. If it's like that, you hold your cable, fold it over where you want the bend, because you want roughly the middle of the spring in the center of your bend. Okay, so obviously we've got a short end here, so we're just going to fold it over at that top, so it's like that. Okay, so this is not too bad, but you're going to want to warm the center of it up, or wherever your bend is, so you can do that and call this whatever movement you want to call it. So you want to bend that over, and then what I tend to use my knee, so it's not full. Don't go mental with it, because what will happen is you'll end up getting a really, really weird sort of lines in it, and because that spring's in the center, you're gonna get a good bend. So what you'll tend to find as well is that the conduit will want to open up itself, so you'll need to sort of go over it a little bit and let it settle. So I think you can agree that's pretty decent on a 90 for a bit of plastic conduit, and there's no major ripples. So when it's really cold, and sometimes you can get lower quality conduit, it will ripple like mad, and sometimes it will fold, especially if your spring's a bit worn out, but they're like a couple of quid. And that's basically how we go about doing that first bend. So the next stage, I'll try and do this here. So if you imagine I've got an accessory down here at the bottom, we're now going to try and put, and we've got a bend in like this one, so we're now going to put that in. So we need to try and keep everything sort of parallel. So if I can, I'm going to try and put that bend in so it's coming out this way, because my wall is coming this way, so obviously it's easier when you've got a bigger bit in there. So again, make sure it's nice and warm. And you've got to try and keep, this is the tricky bit, is trying to keep that horizontal to when you're putting your bend in. Okay, see as it's trying to open back up. So it's sort of settled down now. And there you have it. And then the reason why you have your cable on, because if you don't, you are definitely not going to get that spring out of there. So when you find with your springs, when they get a bit worn out, you might find that one of these is rippled or it's sticking out, so it's bent a little bit. You need to get rid of it, because it's not going to work. So that, if you can see, is a pretty decent, and you can just manipulate the last little bit. So it's a pretty decent set on there. And that is literally, practice makes perfect. So if you do get some offcuts, so if you're an apprentice and you're not sure, I mean, a few quid and you can have a go and start creating some really cool shapes and things like that. The less accessories and bends and, you know, physical bends that you can buy, obviously it always looks better doing it this way. Getting the cable through, which is obviously the next tricky bit, and obviously the longer and more bends and things like that you have in it, obviously it's a lot harder. So you're going to use your fish tape on there, tie your cable on. Like I say, if you're using singles, it's loads easier, but obviously in this instance we're using twin and earth. So with the twin and earth, you can use a bit of cable lube, which I know is a little bit cheeky out there, but the cable lube makes a massive difference, and it will obviously then pull through nice and easy. And what you'll find is it'll go around the first bend easy enough, but then when it's coming around to this one, going down, all of a sudden it starts getting really tight. So that's where the cable lube comes into its own. And that's basically the best way I find of taking care of all your conduit. So like I say, with your polishing side of things, get that all sorted, and then you will find as you're working, especially dealing with the spring, you'll end up with handprints. And then with the final finish is obviously just go over it with some big wipes and it'll all be nice and neat. So that's how we go about doing the old conduit bending, and obviously nice little tip there for cleaning all the weird marks and stuff, black marks and stuff on it. So let's jump back in there and get on with the actual testing side of things and fit that MCB, sorry. Okay, so we've got the cable in, so it's prepped at that end. So we've got this end now, it's isolated off, locked off at the other end. So what I need to do now is get the MCB fitted, which I'm going to drop in at this end. So I need to get that bit sorted now, and then we'll go through all the testing procedure. So I'll just get that fitted, and yeah, get back to you, 2 seconds. Right, so hopefully you can see all this. Okay, so it's a little, because it is super tight. So got the MCB in now, so that is our circuit that we're going to be using. So I've semi got the cables where I need to be, and obviously at the other end we've got them ready to go for our accessory. Okay, so first things first, we're obviously going to be using the MFT on there, so multi-function tester. I mean, I use a Mega, there's different makes, but I always find Mega the best, to be honest. And it's something that I've always, straight from college, is what I've used all the way through. So first things first, I need to make sure I null my leads to make sure that there's not any resistance. Well, because there's resistance in the lead, so you need to make sure you take that out. So I've got 0.1 of an ohm, which is in the resistance of my leads. So we need to get rid of that. So I wanted the tone off. So obviously now that's set to 0. So now that will literally just test the actual cables, nothing else, not including these. These are basically obsolete now. So the other thing I need to do then is link up. So you can do it on this instance because of the camera. It's going to be easier to do it at this end. So I know that it's literally just that. But you would normally, what you would do is link your, tell you what, I'll do it here actually. Let's do it right for you. Let's do it right. So you link your line conductor and your CPC, and then you clip the other ends onto the accessory, which you probably aren't going to be able to see. Okay, which is, tell you what, let's turn it around. So you can see there just over my shoulder. I know it's really tight, sorry guys. So that is on there. So you're literally resting, just so you know, this is nothing glamorous about all this. You're literally resting on top of a boiler, hence the reason why you're just falling over now. So we've got a resistance reading of 0.05, which is what needs to go down on your certificate. So I'm just going to grab the iPad. So obviously on our certificate, okay, so we've got what it is. So our R1 plus R2, we'll clear that out, is obviously, which now dropped down to 0.04. Okay, which is what I kind of expect anyway, considering that it is such a low. Obviously, just the circuit's tiny, isn't it? Let's be honest, it's not going to be massive. Okay, so next phase from that is doing our insulation resistance test. God, it's tight in here. Okay, so we can do our insulation resistance test. So get rid of those. So we'll set this to 500 volts. Okay, so now in the case of you've got, you can't guarantee that you've unplugged everything. Also, you might have a load of LED downlights that you can't drop, you can't get to all these sorts of things, so it's not appropriate. You can test at 250 volts, okay? So you can also, once you've done that, you can then link your live and neutral together and then test that way, but you must make sure that you write that down on your certificate and why you've done that. But obviously in this instance, we've got nothing else connected, so we'll do it the right way. So we'll go onto your CPC, press and hold your test, and that should say 999, which is perfect results. Obviously I line to neutral, again 999. Your neutral to line, 999 again, and there you have it. Okay, so you've now got, you know that your insulation resistance has passed, so it's automatically set on here. Oh, okay, I lied, it was normally. So again, enter all your results in. Oh, that's 3-phase, sorry, my bad. Okay, so what we're going to do then is we're then going to put all the accessories back together. So we're going to get that all wired back up, and then we're going to do our ZS. So there's two ways of doing this. So you can get your ZS results by calculating. So for that is obviously you find out what your ZE is and you add that to your R1, R2, and that is probably my preferred method, if I'm honest. The reason why I prefer doing that is because I'm not exposing myself to more live parts when you don't have to. So that's my preferred method. But we'll test this out the other way. Hopefully you can see it because it's a bit tight, so bear with me. Okay, so we're going to move on to ZS testing. So what I'm going to do with this one is I'm going to do it as a 2-lead ZS, which is a brilliant function of the Mega, to be honest. So what we need to do now is move our setting round. So it will automatically ask for a 3-lead test. Okay, so we need to change that because we don't want that. We don't want a two lead high, we want a 2-lead low. So we don't want max ZS because that's what you use for your ZE. You want obviously a Z reading. So we need to be making sure, so this is why I don't like doing so much of this way. I like to calculate my ZS's, but we will do it nonetheless. Okay, so we will be redoing the label here. So we'll energize and you'll see here it will show I've got 242 volts there. And it should give me around about 0.3 something or other. So I know what the ZE is. Okay, so it'll work through. 0.36 is my ZS reading. Okay, and that is 641 amps at that point. So that is how you go about doing a 2-lead ZS reading. So obviously now I need to turn that back off, put the accessory back, so because as it stands right now it is like that. Okay, so I need to put that back on. It's powers off. Like I say, in a normal environment, if you were in another house, and I know it sounds a pain in the backside, but the board is miles away, you've got to make sure you lock it off, lock it back off, because you don't want to be having your hands in there and somebody, all innocent, just comes and turns it back on. So we need to record that result as well before we forget, because that will definitely happen, because it's amazing how short my memory is. So 0.36, okay. And that's basically the ZS. Hold on, let's get that back on. Okay, so the accessory's back on now. She is all in and wired up, ready to go. Okay, so this is hard for you not to fall off here. So what more tests we need to do? RCD testing. Okay, so we've got RCD at the other board. So what we're going to do, because I know on this board I've got sockets. So again, you can test at source. So when we're doing a full board change and it's all RCBOs all the way down, we always just test at the board and just test purely the RCD. So we've not got that situation. I'm not going to disturb the rest of the house because they've got the football on, the World Cup is on. So what we're going to do, we're going to do an RCD test, and we're going to use one of these kitchen ring sockets in here to test the RCD back at source, because you need to make sure you've got RCD protection on here and it trips out in time. So let's get set up. Okay, RCD testing now. So we need to set our MFT to 1 times its current rating. Okay, so we need to make sure that we have that now, because you used to do all the full cycles through 5 times and all the rest of it, but you don't anymore. So we've got a 30 milliamp, RCBO at the other end. So what we're going to use is our plug-in tester, so our 3-lead plug tester. And then we're going to set that up. Now you'll notice in there you've got a 0 degree, and so you have to test it on both waves of the cycle, because if you don't, you're only doing half a job. So obviously we'll whack that in. You'll notice it will go dark in a second, so we'll try and bring you in a little bit closer. So normal kitchen ring socket, which is what is plugged into. I've got obviously the uni lights going because it's going to get dark any second. So we've got 243, 42 volts on there. So you press test, And there she's tripped out. So on there, that is tripped out at 28.7 milliseconds. That's what that's tripped out at. So now we need to go and re-energize that. Okay, so that's re-energized now. So now we need to make sure that we're doing it at the 180 degrees on there. So you can press that. So you press your little arrow and it will show you the 180 degree cycle, if you can see that. And then we basically go again and it'll trip out. And I've got now a reading of 38, if you can see that, hold on. 38.5. Let's go and re-energize that. Okay, so there's one more test that you need to do for RCDs. So on each, whether it's an RCD that controls on your split load board or it's an RCBO that controls individual circuits like this one, there is a test button on there. You need to make sure, which is called a functional test. You need to make sure that you're hitting that and that actually activates. Because if it doesn't and it's faulty, that is it. It has to go. It has to have a replacement. So that is what the sticks. And the reason why you have the test, every 6 months, it used to be quarterly. That is for that reason, to stop the RCD sticking. So as always, you record down your highest results, which is what we've done. So that falls well within our permitted times. So for this installation and this type of RCD. So that's pretty much it.